Let's learn calculus without knowing calculus. That is the name of the game. That is what the series is going to be all about. Calculus. When somebody says calculus, you have this notion in your head, there's going to be some scary mathematical symbols. There is going to be some algebraic equations in front of you. You have to solve these equations to pass some exams. You have to solve these equations to pass some competition exam. Let's throw all that out because calculus is not just about passing some exam. Calculus is not just whole representation of these scary mathematical symbols, some equations. Calculus is a language. Like any other language, you have words, you have grammar. You then use these words and grammars to create sentences. Once you have the sentences, you write paragraphs. Once you have paragraphs, you write books, you write essays, essays that are interesting, essays that make sense. Same way, calculus is a language. Once you have mastered the basics, you will be able to take the the basics and the grammar and translate the physical world into digital twins which you can simulate without using the physical world. You have the digital version of the physical world. That reminds me of the movie Matrix, where in one of the scenes, Cypher is having conversation with Neo where he is telling him, look, I don't see pixels in front of me. I don't see zeros and ones. What I see is a brunette, a redhead, a black. Same thing is that he has have the basic understanding of the system in a way that he is able to translate these symbols into a reality. This is the goal that we have in our mind, that by the time you learn the basics, by the time you learn the grammar, by the time you're able to make the sentences, by the time you're able to write an essay, you should be able, when you look at that time, when you look at an equation, you will be able to say that I know what this is. This is not about solving an equation or passing an exam. I know what this is because calculus is a language which you use to describe physical world into a digital reality. So what is the goal of our series of these lectures on calculus? Well, first we're going to learn the basics. We're going to learn the building blocks. We're going to learn the grammar. We're going to learn how to use these, create sentences. I'm not still using the formal language of calculus. We are still going to stay with the what you know intuitively, what you've been doing in your head. So once we have learned the basics, we're going to use that to create models of the physical world. We're going to make some real models. We're going to turn these the physical reality into a digital reality. Once we have a digital mathematical model, we're going to write some code to simulate the digital twins that we have created from the physical reality. That is the goal of our series. Let's start. Calculus. What is calculus? Calculus is mathematics of change. So when somebody says change, change is something that is happening all the time. Change is everywhere. Your life itself is a constant flow of change. Knowingly or unknowingly, we think in terms of calculus. We do calculus in our head. The difference is you're not using those mathematical symbols in your head, but you are doing calculus. So when we started, we said that calculus is a language or things that you do all the time. That is true. Since calculus is mathematics of change and change is all the time, so that means you are doing calculus all the time. Let's take an example. Social media pulse. You post a video. Once you have posted a video, at that point you have no views. After 30 minutes, you come back, you open your phone, you look, oh, I got 200 views. Now think about it. What did you do in your head? You said that I have gained 200 views in 30 minutes. That is the speed at which you gain the views. Or you can say this is the Rate of change of views. That is calculus. That how fast your video is growing or how fast the views are growing. You come back after another 30 minutes. So since your speed is 200 views, in 1 hour you have 400 views. Then you come back after, let's say, 4 hours. You see that number of views you have is 10,000. That was not expected. If we go by the constant rate of change of the views or the speed of change of views, your video has gone viral. Now what this paradigm has shifted from measuring the gaining the views over time, now we are measuring how fast the views are being gained now. Now you are measuring the growth of speed. First you are measuring the speed of the gaining views, and now you're measuring the growth of speed, acceleration. You look at the video's profile, you look at a number, that how many views you have got. You see, let's say that you have got 150,000 views. From where did this number come? You already are doing this thing in your head that I was gaining views at this speed, and if I add them up over a period of time, this growth will lead to an accumulation of these many views. You are accumulating, you are adding things up, you are summing things up. You have a number in front of you. Again, this number is not going to be static. It's going to change as more views are coming in, but at a given state of time, at a given point in time, that number is static, means you have added up numbers in your head that at this speed, at this change, at this rate of change of gaining views, this is the number that I have got. You have built a reach. So again, this is just a total that is the result of adding up every bit of the view growth that has happened over time. That is calculus. Now let's just look at some more examples. You're pouring water in your cup or glass. You don't need a mathematics textbook or some professor to tell you that as more and more water is being poured into the glass, the level of water in the glass is going to rise. In your head, you already know that the faster you pour the water, the faster the level of water is going to increase. So you have the change of speed, the rate of change calculus, the accumulation of water height calculus. You are doing it every day. You just you're not just putting the mathematical or the scary symbols in front of it, but you are doing calculus. Let's look at the next example. You are driving a car, then you have a red light in front of you. You are doing a math, you are trying to compute in your head that how much brake pedal I have to push to ensure that the car is going to stop at the light line just before the red light, or how much speed I need to decrease so that by the time I reach that line or the red light, the car has stopped at that light. Think about it. You are doing calculus, the rate of change of your speed, that how much do you need to slow down or how much pressure you need to put so that you stop. Let's look at a real world example. In the industrial example, you are producing biomass. You already know in your head that the more nutrients you add, the more cells will grow. So let's translate it to the world of calculus. You already have the rate of adding the nutrients that is resulting in the accumulation of the biomass production. This is all calculus. You're already doing it intuitively, knowingly or unknowingly. Difference? Not putting mathematical symbols around it. Now let's put the calculus. Now start putting some words. Start learning some words that calculus uses. The first thing that we did, we were tracking how fast the views were growing, how fast we were tracking the pulse of our video. That is the speed of change at any specific time. In calculus, it is called differentiation. You will see this is will be represented in some equations as dx by dt. It may not be x all the time, it may not be t all the time, but what this dx by dt translates to is how much x is going to change over a period t. Dx by dt, means differential, that it is the rate of change of x over time t. That is our first word in calculus, differentiation. Next thing that we learned was as the views were growing or as the water was being poured, the number of total views, your reach was growing up. It was adding up all the bits of change that have happened, all the views that you have gained over a period of time. You summed it up. In the world of calculus, that is called integration, represented by a very elongated version of S, sum. So you can look at that way, that integration represented by elongated version, a special S, summing up. Let's go to the next concept of calculus. When you posted the video, you were gaining views. You're not gaining views out of thin air. There were some factors that were driving the virality of your video. What are those factors? There are two critical factors you have. You already know in your head that the more network footprint, the more followers, more friends, more subscribers you have, it's more likely that your video will be viewed by all the existing followers. Other factor is the content. What is the subject of your video? Because not everybody likes every kind of subject. If you post a video that is interesting, that matches the interest of your followers or your friends, your subscribers, it is more likely that they will watch it and more likely that they will forward it to more people who are not your subscribers or followers yet. That will grow your input, your network footprint. So what is the growth of the virality of your views, or what does this mean for video to go viral? That is the growth of your views. Depends on network footprint and content hook. Content hook means what is the subject of this video that you have posted and how many existing subscribers, because the bigger your network footprint you have and the subject, you already are kind of know in your head. Again, think about it. Without doing calculus, you already have in your head that you can expect what kind of video, the view growth that is going to take place. Is it going to go viral or not go viral? Let's look at the car. Every car or every vehicle has an engine. An engine has a horsepower. Horsepower again means that how much capacity it has, which will give the power to the engine. Then you have pedal pressure. In your head, you already know that the more pressure you put on the pedal, the faster the car is going to go. The bigger the horsepower, more powerful your engine is, the the car or the vehicle is going to go faster the more pressure you put on the pedal. So again, translating it back to that, you already in your head, you already know that the car is going to accelerate more if more pedal pressure is used and the horsepower. For a given car, the horsepower is not going to change. The one that you have control on is your pedal pressure. But in your head, you know that what kind of acceleration you can expect if you put what, depending on the pedal pressure you have put. Now this takes us to the next part, is the grammar of calculus, where we say that every action results into a result multiplied by a growth factor. There is no special This is all common sense. This is all intuition. This is everything that you are already doing in your day-to-day life, in your head, without putting symbols, without putting some mathematical equations to it. Now what we are doing is we are just translating all that common sense into a language that is called calculus. So what is the action? It is the independent, in calculus, it is the independent variable. Why it is independent? Because it is not dependent on some outside factor. For example, in case of car, is pushing the pedal, you control it, not somebody else. In case of views, it's the post, you control it, what you're posting, not somebody else. That is the independent variable. X. What this pushing the pedal results into? It results into the speed of the car. Acceleration. In case of the video, that results into views. It is a dependent variable, meaning why it is dependent? Because it has a dependency on the independent variable x, meaning that the speed is dependent on the pedal pressure. The views are dependent on the post. That is why it is a dependent. And all this relation is controlled by a very important factor. We call it a growth factor. In world of calculus, you will come across the word a constant. So in case of car, that is your horsepower. That drives the speed, the acceleration. In case of the social media video, it's your subscribers, followers that counts, that dictates the growth of your views. The bigger the growth factor, let's say in case of video, the more likely that the the views are going to grow. In case of the car, the bigger the horsepower, for the same amount of pedal pressure you put, the faster the car will grow. That is what you're looking at is the mathematical sentence that the result y is a combination of a growth factor and your independent action, independent variable x. X and Y is something that is traditionally used, X, Y, Z, as the variables. That doesn't mean that you cannot change it, but this has been a convention that the variables are represented by X, Y, Z, and the constants are represented by the earlier alphabets A, B, C, and some other Greek symbols. But that is how mostly these equations are written. Somebody will call it function, somebody can call it equation, but at the end of the day, now we have two things that we have taken together and created a calculus sentence, a mathematical sentence where we say that the result is it depends on the growth factor and the action. So what did we learn so far? We have learned some basic language of calculus. We have tracked the rate of change over the pulse in world of calculus. That is your differentiation. Then we learned that when we accumulate all the change that has happened over the time, we summed it up. In case of the videos, that was the reach or the total views. That is called integration. Then we learned the actions and the results, the variables. That in calculus, there is an independent variable. Why it is independent? Because it does not depend on any outside factor. You control that action, x, that results into a result, independent variable. So we have differentiation, integration, we have independent variable, dependent variable, all that combines into a function. I call it an equation. So what is a function or equation? A function is the rule of the system. So now we have used our basic words, the grammar, to create a mathematical rule, the function. And in the function, there is a constant, that growth, that scales your result. So these are the basic building blocks of calculus. If you again think about it, you've been doing it knowingly or unknowingly in your head without putting any mathematical symbols, but now we have put the calculus symbols or the formal calculus definition of your common sense thoughts. So that is the basics of calculus. Where we are heading with this in next chapter, we're going to use all the building blocks that we have learned and try to create a very simple mathematical model of the growth of a living cell population. So we're going to see that how all the basics that we have learned, how do we create a digital twin of a real world biological system. We're going to turn this our biology in the later chapters. We're going to turn this biology or our mathematical symbols or any kind of digital twin that we create into a working code where we will be simulating life, where you will be able to see that all that you have learned so far into action. I hope I was able to explain some basics. If you like the video, please do subscribe. And for more information, do visit our website, academy.sapsentinel.com. I'll see you in the next chapter video. Till then, take care. Goodbye.